third graders. I hope you all are doing really well. I hope you're staying safe and healthy, that you've been able to go outside and enjoy the sunshine. We are going to continue on our journey of learning in Module 5 with about fractions and learning about now how our wholes kind of tie into that. And so you are going to be continuing to learn about equivalent fractions now here in lesson 24. So as always, make sure you have a notebook, piece of paper, pencils, markers, crayons, pen, whatever you like to use to draw, as long as you have lots of extra space and you're ready to take some notes. Today, by the end of your lesson, you should be able to confidently say, I can express whole numbers as fractions and recognize equivalence with different units. So let's get started. Before we get started in our meat and potatoes of our lesson, we are going to practice some fluency, and we are going to say the fraction represented by the dotted line. I would like for you to go ahead and copy this number line on your notebook. And we are going to say the fraction on the dotted line that is represented on the dotted line. So we have two equal parts in one whole. That means that this one line, so we have two equal parts, that means this is 1/2. I wrote the fraction below the dotted line, so this is 1/2. So this chunk is 1/2, this chunk is 1/2. So 1/2, 2/2. So now we're going to write the fraction 1/2 is equal to 4th. So that means that we are going to now make this into fourths. And you might be asking yourself, how in the world am I going to do that? Now I know that I can break this section, the 1/2, actually in half as well, and then the second half into half. And now I have how many equal parts? I have 1, 2, 3, 4. I just made fourths. Now we are going to start by labeling this one. It says this one is going to be, this first line is going to be 1/4. And our second line is going to be 2/4. We can stop right there because you can see that 1/2 is equal to 2/4. If you wrote 1/2 equals 2/4, go ahead and give yourself a pat on the back. You guys are so smart. You're doing a great job. We're going to move on and look at dividing by 7. I do want to encourage you all to continue to practice your multiplication and division facts. So if you are still struggling with some multiplication, continue just memorizing those facts, and then you'll be able to work on division. Remember, division is just the opposite of multiplication. So once you know how to multiply, division will be a piece of cake. We're going to start off by skip counting because skip counting will help us in seeing how to solve our division problems. So we're going to start off with 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. Now, when you look at this first problem, 21 divided by 7, we can look and find the number 21 in our skip counting and then count over. How many numbers did we skip count? How many did we do? So it's 7, 14, 21. That's the third number over. So 7 times 3 is 21, or 21 divided by 7 equals 3. It's the third number over. 49 divided by 7, you're going to find the 49, and you can think, okay, that's 1, 2, 3, 4, 5, 6, 7. That is the 7th number over. So 49 divided by 7 equals 7, or 7 times 7 equals 49. Now 7 divided by 7, you just find the number 7. It's the first number, so that one is number 1. That one's easy peasy. Identify 28 in your skip counting line, and that is 1, 2, 3, 4. That is the 4th number over. So 28 divided by 7 is 4. 35 is the 5th number over. I'm going to show you how I found that out. It is 1, 2, 3, 4, 5. And so 35 divided by 7 is 5, or 7 times 5 equals 35. And then 42 divided by 7 is 1, 2, 3, 4, 5, 6. It is the 6th number over, and that means 7 times 6 is 42. Okay, we're going to look at our application problem, and I would like for us, we're going to read it, we're going to take it pretty slow, and we're really going to have to break apart or partition our number line in different ways. So make sure you draw a long enough number line to really break it apart. You should label it with the endpoints 0 and 1, and you're going to need to have 2 different colors. You're going to need to get ready with 2 different colors. So I do want us to read it first to figure out how are we first going to partition our number line. It says the zipper on Robert's jacket is 1 foot long. It breaks on the first day of winter. He can only zip it at 8/12 of the way before it gets stuck. Draw and label a number line to show how far Robert can zip his jacket. So when we look at 8/12, we know we are going to break the entire hole, that whole 1 foot long, into 12. Now, I really want to encourage you guys to try your best to space them out so that they're equal. So we're going to get started. So I'm going to do 1. I'm going to try my best 2. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's see if I have 12 equal spaces. Now they might be slightly different, but I tried my best. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I do have 12. Now we are going to label the number line to find 8/12. So I have 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12. So I'm going to write that at the top. Now our question and our problem is not done. So we do see that's how far he zipped up his jacket. And now it's asking us to divide and label the number line in thirds. What fraction of the way can he zip his jacket in thirds? And so this is kind of tricky because we already have all of these lines here, and you could kind of guess where the thirds are, but it's actually a really easy way for you guys to be able to see it. I'm going to use a different color, and this is the time when I would like for you all to get a different color. And we're going to think, so 12 divided by 3 is what? Now, if you answered 4, that is correct. So 3 times 4 is 12, and 12 divided by 3 is 4. And so we can actually break our number line evenly into thirds. We can do that by counting over 4 lines. So at every 4th line, you're going to put a mark, and you're going to notice that that makes it into thirds. And I'm going to show you exactly what I mean by that. So every fourth line, you're going to put a mark for thirds. So 1, 2, 3, 4. I'm going to color over it with my pink. Okay, now we have 1, 2, 3, 4. And I have to be careful. You don't want to cover up your number. And then 1, 2, 3, 4. Now look, I have now 3 equal parts. I have thirds. Now we want to label our number line into thirds as well. So here's 0 thirds. We're going to label it on the bottom of our number line. We have 1 third, 2 thirds, and then this one would be 3 thirds. Okay. So now it's asking, what fraction of the way can he zip up his jacket in thirds? So we're going to look at this as being our equal or equivalent fractions. So he can zip it up 2 thirds of the way. So 8/12 is equal to 2 thirds. Now it's asking you an even trickier question. It says, what fraction of Robert's jacket is not zipped? Write your answer in twelfths and thirds. So what is left to get to 1 whole? So if we go from 2 thirds to 3 thirds, what fraction in thirds to start off with? How many more thirds would we need to get from 2 thirds to 3 thirds? You would only need 1 third more. So which fraction is not zipped? It's 1 third. Now, what fraction of twelfths is not zipped? And we're going to count with our nut lines. So we have 1/12, 2/12, 3/12, and 4/12 left. This one is tricky. This is a very tricky application problem. I'm going to briefly show you my next picture. So if you had labeled all of your fractions at the top, you would have seen that we counted all of our twelfths. And I definitely recommend you doing that. And then they answered it with full complete sentences. So part A was Robert can zip his jacket 2 thirds of the way. And then for part B, we answered it as 4/12 or 1 third of his jacket is not zipped. So we wanted to see what was left over right here. Okay, we're going to move on. So today we're looking at number bonds. We're going to look back at number bonds and seeing how that helps us think of our wholes. So it says in our whole, we're going to write the equality that shows how many halves are equal to 1 whole. So on your paper, I would like for you to draw your number bond, and you're going to draw one big circle with 2 legs, and in each of those are going to be 1/2. So I'm telling you that 1/2 and 1/2 is equal to 1 whole. But what could I do as a fraction? How would I write that as a fraction? If you said 2/2 or 2/2, you are correct. And you're going to see it come like that. So 1 whole is equal to 2/2, or 2/2. Now we're going to do the same thing. So now I'm asking you 2 different questions. I want you to think about thirds. Okay? So how many thirds are going to equal 1 whole? So if I have 1 whole, how many thirds are going to equal 1 whole? So there should be 3 equal parts. And what is going to go in each of these parts of our number bond? If you said 1 third in each, you are correct. So I would say 1 third plus 1 third plus 1 third is going to equal 3 thirds or 1 whole. Just like that. So you're going to see right here in your whole, write an equality that shows how many thirds are equal to one whole. One whole is equal to 3/3. Make sure you are writing these down. Now we're going to try one more time. Now we have 6. So here is my whole. Here's one whole. How many 6 equal one whole? 6 parts equal one whole. So you should have 6 spider legs, is what I like to call them. And in each of them, you're going to write 1/6. So here are all of your spider legs. And in each of them, you need to write 1/6. So 1/6, I'm not going to do that because it takes me a lot longer on my computer. So 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. Now, what does that all equal as a whole? How many 6 do I have to make one whole? If you answered 6/6, you are correct. So 6/6 equals one whole. One whole equal part. Now, in your notebook, I do want you to draw this number bond. And I want you to think, is this number bond true? Why or why not? Now we have to think, how many legs do they have? And then what is our whole? What is our total right here? So if you look at what's on the bottom, the denominators are not the same. So what they're trying to get you to look at is comparing different fractions and asking yourself, are they still equivalent? So this is telling us that we have 1, 2, 3, 4, that we have 4 fourths. Okay, but then what's in our middle? We have 1/2 plus 1/2. That would be 2/2. Now, I've been telling you guys since the beginning of our unit that when the numbers at the top and the number on the bottom is the same number, that equals one whole. So if I have 4/4 and I also have 2/2, they're both equal to 1. So what does that mean? Are they all equal? Is 4/4 equal to 2/2? They are equal. And so is this number bond true? The number bond is true. So if you said that the number bond is true, go ahead and make sure you write down an explanation as to why you think it is true. But if you disagree with me, go ahead and write down why you think it's not true. You may even draw a number line to show your example if you'd like. Now let's try another one. Draw in your notebook to make this number bond. Is this number bond true? Why or why not? Now I am going to draw a number line to show you why I think this number bond is true. So I'm going to start off by drawing my number line. Okay, and I'm going to label the endpoints as 0 and 1 because we're talking about one whole. Now I'm first going to notice that this is broken apart into thirds. So I'm going to break it into thirds. Okay. So I have 1/3, 2/3, and then as a whole, I have 3/3. Okay, that's one whole. So we're going to put in parentheses that this also means one whole. Okay, now it's asking us, does 2/2 equal also one whole? I want us to look at our number bond, and I'm going to break this up, or our number line, and I'm going to break this into a half. This is 1/2. and then this is going to be 2 halves. So does 2 halves, is that equal to 3/3? The answer is this true? And the answer is yes, it is true. And you need to explain why. Either explain in words, or you can draw a number bond on your notebook, or a number line, I'm sorry. They're both equal to 1 whole. They all make up, they have their complete parts, and so they are equal to 1 whole shape, or 1 whole figure. Now, what we are going to do is we're going to practice, and so as we're walking through this, this is something you're going to see in your practice work today. This is something I would like for us to work on together in our video. So I'm going to only go through, I'm going to go through a few examples, and then you're going to have time to practice later on today on your own. So please be taking notes, because it will be really helpful to go back and reference your notes as you complete your work on your own. We want to read the full directions, and it says to complete the number bond to show how many parts make a whole. Partition the number line to show the given fractional unit, and then label each fraction. So this first one is talking about fourths. So they already drew 4 parts coming out of the 1 whole. So inside we are going to draw 1/4, 1/4, and 1/4. So 1/4 plus 1/4 plus 1/4 plus 1/4 is going to give us 4/4, or 1 whole. Now, do not forget they're also asking you to label the number line, and they want you to be labeling the number line so you can see how each of these is going to equal 1 whole. Okay. Now, our next number is asking us to partition it into fifths. And so we're going to look at fifths, and so that means on your notebook, you should have 1 whole with 5 number bonds coming out. Now, I am not going to write 1/5 in every single one of them, but I do expect in your notebooks you will. So it should be 1/5, 1/5, and then you're going to do that for the rest of them. And that will give us 1 whole. 1 whole is going to equal 5/5. That means on our number line, we also need to show the same thing. We need to partition this into fifths. So I have 1, 2, 3, 4, 5. And so you would go ahead and label this. You can even start with 0/5. And this will be 2/5, and 3/5, 4/5, and then it's going to show us 5/5. Okay, now our very last one is showing us 6. Okay, and so you're going to draw 6 spider legs coming out of your number bond. All right, and so inside of each of those, what do you think is going to go inside? It's going to be 1, 6. And you're going to repeat that for all of the spider legs. Now, we know because we're talking about 6, we need to figure out how many 6 equal 1 whole. So I'm going to partition this into 6 equal parts. So I'm going to say 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5, 6 equal parts. And if I started labeling this, I would know that this would be 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, and then when we get to 1 whole, it is 6/6. So what they're asking you to think about is use the fractions above to complete the number sentence. 1 whole is equal to 4/4, which is also equal to 5/5, which is now also equal to 6/6. Do you all see that? It's now a one complete whole. They might have more parts, they might have more sections, but they're still one whole complete pizza, or one whole complete figure. All right, let's move on to one more example. It says Mrs. Ramirez gives her students each a strip of paper. Jonah cuts his into 6ths. Casey cuts hers into 4ths. Jonah says, I have more than you because I have 6 pieces. Is he right? Explain. So we're going to look at Jonah, and we're going to look at Casey. Now, Jonah cuts his into 6 equal parts. So we're going to try our best to cut this into equal parts. Now, you are going to want to draw a rectangle, 2 rectangles that are the same size. So I have 1, 2, 3, 4, 5, 6. Now you can see they're not all the exact same. I tried my best, and it's okay if they're not exactly the same exact size. Just try your best to make them as equal as you can. And now Casey cuts hers into 4ths. 1, 2, 3. Now I have 4 equal parts. And it says Jonah cuts his into 6, and Casey cuts hers into 4ths. Jonah says, I have more than you because I have 6 pieces. Is he correct? So if he has all of his pieces and she has all of her pieces, what do you think? Does he really have more than she does? No, he does not have more than Casey. They have the same. So he is incorrect. He is not correct because Jonah has 6/6 and Casey has 4/4, and they both equal one whole. Today you are going to be looking at your homework. It'll look slightly different than this, but exactly what we were just doing earlier is where you're going to create a number bond. You're going to show me how many fractional units you need to make one whole, and then you're going to break apart the number line. Third graders, I know you guys can do this. You're doing a great job. I miss you all a ton and hope you're staying safe, and I can't wait to hear from you soon.